Once you become familiar with control components, you can start to combine them together to create more interesting results. Like a game of Mousetrap or a Rube Goldberg machine. You can wire these components together to trigger an event only under very specific conditions. You can get quite creative with your use of control components and accomplish a wide variety of tasks. Eventually, you will hit a wall. You can accomplish a lot with these simple tools, but there will come a point when you need to move on to a more complicated coding language, like our script or block controller. However, in this video, we'll walk through a few examples of things that you can accomplish with the control components, as well as take a look at a few of the remaining components that we haven't seen yet. If you want to look at just one of these in particular, feel free to jump to the timestamp where each section begins. Here's a common scenario. You need to put the gain fader for a microphone onto a UCI, but that UCI is going to be operated by a human. And I don't know if you've ever met a human before, but they're mostly terrible. If you give them a fader, they are guaranteed to slam that fader all the way to the top, which is never a good idea. Instead, you can add a custom control with a level fader and customize the range of that fader. I'll restrict this one between -20 decibels and 5 decibels, since that's all the flexibility I think they'll really need. I'll wire this control to my original gain knob and add it onto the UCI. The user will never know the difference. They think they're maxing out the system, even though there's still plenty of headroom. Let's also grab the channel's mute button so the user can turn the microphone off. Since I've capped the fader's lower limit to -20 decibels, this bottom range is still audible. So it would be nice if this mute would automatically engage when the user turns the fader all the way down. For that, we can add a simple control function. Regardless of what range I've customized for this fader, I know that when it's all the way down, its .position parameter is 0. So I'm going to add a comparative statement with another control that will already have a position of 0. I'll add a toggle button, which by default is off, and select a control function of position equal. When the fader is at the bottom, its position is 0, which equals the toggle button that also has a position of 0. So that satisfies the conditions of the position equal control function, which outputs a 1 that engages my mute button. Now, when I pull the fader down, it automatically engages the mute. If I move the fader again, its position no longer matches the toggle button, sending a 0 that will disengage the mute. I could still manually engage the mute, but when I choose to move the fader, it will automatically open the mic again. We've made a simple solution to a simple problem. Buttons are great for binary behavior. When you need a 1 or a 0, they're perfect. But what if you want a button to output 2 other values? For instance, let's say we want a simple button that will toggle the gain of an audio player between a loud setting and a quiet setting. We don't want to mute it and unmute it, but instead toggle the gain's value between 5 decibels and -10 decibels. How can we do that? There are actually a lot of different ways to accomplish this. It all sort of depends on how your brain works. Let's look at a few methods. The easiest way I can think of is to use snapshots. You could use a 1 and a 0 to activate a snapshot load button, which can recall a saved value for your gain control. Let's create a new snapshot bank and associate our gain knob with that bank. Then we'll set the gain to 5 decibels and save snapshot 1, set it to -10 decibels and save snapshot 2. Then I'm going to grab a flip-flop. You may remember that its out and not out LEDs alternate based on the flip-flop state. I'll expose the control pins to load snapshots 1 and 2 and wire them to the flip-flop. Now I could put this state button on a UCI, giving the user a single button which has the effect of loading 2 different values to the gain knob. Let's look at another method. We could use a control router that directly sends a new value to the gain control. Here we have 2 custom knobs for our inputs, one set to 5 and the other set to -10. The control router determines which one passes forward. We can expose the control pins for selecting input 1 or input 2, and then use our flip-flop to toggle between these options. Alternatively, if you didn't want to use the flip-flop, you could use another button to activate the first router or snapshot option, and then use a control function to invert the position of that button so that when the button is off, it will send an on signal to the second router or snapshot option. These all have the same effect. It's just an example of the flexibility of these control components. Let's take a look at this control component, the status combiner. This is a rare component that only accepts status controls. You can find status controls in almost every inventory item or network-dependent component. You probably recognize these status controls from the default inventory status UCI that lists the health of every device in your design. While this UCI is helpful, it might take a while to look through every status on a design with many inventory items. You can combine them all into a single location by wiring their status control to the status combiner. At the top, the status combiner lists the worst status of all its inputs. If everything in your design is running properly, then it will say OK. But if I were to disconnect one of my peripherals, for instance, that device would disappear from the network and register as a fault. Since that's the worst status of all my devices, the status combiner will report the fault. You can customize a label for each input so it will tell you exactly which device is experiencing an issue. And if you want to ignore a particular device, then you could suppress its status, which will temporarily remove the problematic item from the status combiner's list of things to worry about. We have another video available where a much younger version of me shows you how to use this status combiner to send an email to yourself or a technician. It looks something like this. When the fault LED engages, we can activate the send button on an emailer component. The message of this email can be populated with the text string we get from the combined status control, which describes the error. However, there is a problem with this setup. If the venue resets the system or has a blackout, then there will be a brief period where the core is active, but its peripherals are still initializing. You don't want to get an email telling you the system is broken just because they had a power cycle. So how can you avoid that? Let's use some of our control components to outthink this. We know that if the system is simply rebooting, then it will be okay again in about 30 seconds. Let's use this to validate whether or not we actually hit the send button. I'll introduce a control delay between the fault LED and the send control, and we'll set this to 30 seconds. After this 30 seconds expires, we want to compare it to the current state of the LED to see if the fault is still happening. I'll grab a control function and set this to logic AND. This requires both of its inputs to be true. So if the fault has waited 30 seconds, then the first pin will be true. And if the fault is still occurring, then the second pin will be true, and the function will activate the emailer's send button. If 30 seconds have passed and the system has restored itself, then the original fault LED would be false, which does not satisfy the conditions of the function, and the email is not sent. Again, a simple solution for a simple problem. Finally, one of the questions I get asked a lot is whether we can add a password on a particular page on a UCI. While you can restrict an entire UCI to a user, requiring them to log in with a PIN number, there isn't a native way to require a code to access a specific page. However, with all of the tools you've seen so far in the control components, you can devise your own method. There are a few ways to do this, and this is the sort of thing that would actually be quite easy if you knew some scripting. But if you don't, then we just have to think it out with control components. One of the ways I like to think things through with these components is to write out the desired function and then replace each bit with a tool at my disposal. Here's the desire. If the user inputs the correct password and presses enter, the UCI page should change. Well, I can already see that I'm going to need a logic AND in order to validate whether password is correct and they press enter. So I have a logic and a momentary button for enter, but how can I get a password from the user and test if it's correct? Well, a number of options come to mind, but let me show you my favorite. To get the password from the user, I need a keypad. And don't tell anyone, but I'm going to steal one from a softphone component. If this design isn't already using its maximum number of softphones, then there's no harm in creating one just to use its keypad. I'll add all of its keypad buttons to my UCI page. Here's the trick I like to use to validate the password. I'll create a new snapshot bank and associate the dial string, that's the phone number, with that snapshot. Then I'll input the correct password and save it as snapshot 1. There's a control pin available on every snapshot that you may have not known about. I'll expose this one called Match 1. The match control is an LED that lights up when the design is in a state that matches the configuration saved in the snapshot. So if someone were to type in the same number that I had saved in snapshot 1, the snapshot match actually lights up, indicating a match. I'll use that for the first half of my logic AND. Now, when someone enters the right number and presses the enter button, we've got a 1. Again, there are a number of ways we could use this one to change the UCI page, but I'm going to activate another snapshot since I think it's the easiest. I'll create another snapshot bank and associate it with the current page control of the touchscreen I want to affect. I'll select the secret page and then save the snapshot and wire my logic AND to activate this snapshot. Ta-da! I've got a keypad, I enter the code, and the page changes. I could give the user a simple navigation button to return to the main screen. There are probably some additional tweaks I'd make to this design. For instance, if the user enters an incorrect code, or if the match LED is not active when they press the enter button, then I want that to activate the pin pad's clear button to erase their entry. I bet I could also devise a counter that goes up each time they enter an unsuccessful entry. If they try 3 times, I could also trigger an alarm warning, send a GPIO signal to the lights in the room, aim the Q-SYS cameras to focus on their position, and command the networked video switchers to deliver the camera's feed to every TV in the venue, while calling the police and sending myself an email, etc. The point is, you can have a lot of fun with control functions. I really do recommend that you spend some time playing with them, and hopefully these videos have inspired some ideas of your own. We have an exercise in the control training worksheet for you to complete, but feel free to challenge yourself by thinking of a problem you want to fix and devising a solution. If you find something that you can't do, this may be a time to start looking at the scripting or the block controller. Have fun playing, and we'll see you next time.